On number 29, little letter A, we're asked how many atoms are in 3 kilograms of copper. So I'm going to map out the problem over to the right. I'm given mass, but I'm not quite given grams, so I need to fix that first. I'm given kilograms instead of grams. Now I know kilo means 1,000, so there's 1,000 grams in a kilogram. So if I have 3 kilograms, I would have 3,000 grams. So that's the number I need to use because the box says that I need grams. Then I need to look for the box that represents what they're asking me for. They ask me for number of atoms, which is a type of particle. So I'm going to be going this direction and using these two conversion factors to set up my problem. So first of all, I've got 1 mole over molar mass. When I see 1 mole, I use it, but the molar mass I need to replace with what's appropriate for this problem. So I'm going to look up copper's molar mass on the periodic table, and it's 63.55. That'll get me to the moles box. Then my second arrow has the conversion factor Na, which stands for Avogadro's number, in the numerator. So I need to fill in, Avogadro's number, 6.22 times 10 to the 23rd power, and then just 1 mole on the bottom. Then I put that in my calculator. I'm going to start in my calculator with 3,000, divide by the 63.55 because it's in a denominator, and then multiply by Avogadro's number since it's in a numerator. And I get 2.84 times 10 to the 25th power. And I should be getting a big number like that because they asked me for a type of particle. On little letter B, it asks how many moles of aspirin are in 2 grams of aspirin. So first of all, I ask myself, what am I given? I'm given 2 grams. And I'm going to find, up on my map, I'm going to erase what I did before, and I'm going to find the box that represents what I was given, which in this question is mass again, and they did give me grams, so I don't need to change it. And then find the box where I want to go, which is moles. And that means I'll go through this same conversion factor I used before with 1 mole in the numerator and molar mass in the denominator, but it's a different molar mass than I used in the last problem. I need to use the molar mass of the substance I'm given. So I'm going to pause the video and work that out over to the side. And I got a molar mass of 180.154. And that's the only conversion factor that I'll need because I only needed to go through 1 arrow to get from mass to moles. So in my calculator, I'm going to put in the 2 that I was given in the problem, the 2.00, and then divide by that molar mass that I just calculated. And I get a very small number, 0.01110. So I'm going to go out to 3 significant digits. The zeros aren't significant because they're at the beginning of the number. So I want 3 digits to match the number of digits I was given in the number in the question. My label is moles since that's what they asked me for. On little letter C, they asked me to calculate the mass of 2.5 moles of magnesium sulfate. So I'm going to write down what I'm given at the beginning of my work. Then I'm going to map out my problem. I'm starting with moles, and they want me to go over to mass. So my conversion factor for this problem has molar mass on the top and 1 mole on the bottom. So I'm going to calculate the molar mass of magnesium sulfate so I can plug it into the numerator. So I came up with a molar mass of 120.38. And that's the only conversion factor I need for this problem because according to the map I only needed to go through that 1 arrow. So I'm ready to take the molar mass and multiply it by the 2.5. My answer is 300.95. In my calculator, I'm going to round that so it only has 3 digits, so that'd be 301, just to match the number of digits in the question, 1, 2, 3. And the label, they asked me to calculate the mass, so the label should be grams. And then on little letter D, we are asked for the mass of 1.31 times 10 to the 22 molecules of glucose. So I need to map out my problem and find the box that represents what they've given me. They've given me molecules, which is a type of particle, and they ask for mass, so I'm going to be going all the way over here. So that means I'm going to go this way and then this way. So these are my two conversion factors to set up my problem. So I'm going to start my work by writing out the number from the question. Then I'm going to set up my conversion factors based on what I mapped out. The first conversion factor is 1 mole over Na, which stands for Avogadro's number. And then my second conversion factor is molar mass over 1 mole. So I need to calculate the molar mass of glucose, and I'm just going to do that in my calculator so I can plug it in. And I got 180.156. So we're ready to put this in our calculator now, and I would just caution you, if you have Avogadro's number in the denominator, which we do here, you need to be careful how you put this part into your calculator, because you're going to enter the number from the question first in your calculator, and you need to divide by Avogadro's number since it's in the denominator. And you either need to use the E button so it looks like this in your calculator, or you need to put parentheses around the 6.022 times 10 to the 23rd so that your calculator divides by the whole thing. Then you're going to multiply by the 180.156 since it's in the numerator. And I get an answer of 3.92. It was 3.919, so I rounded up the 1 to a 2. And the label for that, since they asked me for mass, would be grams. Now, if your calculator gave you this number, but like to the times 10 to the 46 power or something like that, that's an indication that you didn't put the Avogadro's number part in to your calculator carefully enough, and your calculator actually multiplied by the power in Avogadro's number instead of dividing. So just be cautious about that.